However, before we sign off, two guests will join me here in Mission Control. Lieutenant Jason Fischbach from the Global Positioning Systems Directorate and I will discuss the Air Force's role in providing worldwide 24/7 GPS capability. And I'll discuss Boeing's role in designing and building the 2F series with Dan Hart, Boeing's Vice President of Government Satellite Systems. An Atlas V rocket is launching the 12th and final satellite in the Air Force's GPS 2F constellation. This is the Air Force's 60th operational GPS satellite, all delivered to orbit on ULA's Atlas and Delta rockets. The Global Positioning System, or GPS, is a space-based positioning system consisting of a minimum of a 24-satellite constellation, providing navigation and timing information to military and civilian users all around the world. The signals are so accurate that time can be measured to within a millionth of a second, velocity within a fraction of a mile per hour, and location to within a meter. GPS is a critical enabler for the United States military to provide national security and a worldwide service for billions of civilian users. Built by Boeing, the next generation 2F series provides improved capabilities for military and civil users, and a new third civil signal, L5, for commercial aviation and safety of life applications. The launch team recently received a final briefing from 45th Space Wing Weather Officer Clay Flynn. The weather for this morning's liftoff is within the launch commit criteria. The probability of violating launch constraints is 40%. The ground winds are 22 knots, gusting to 26 knots out of the north-northwest, and the temperature is 51 degrees Fahrenheit. So the weather looks favorable as we proceed towards a planned T0 of 8:38 a.m. Eastern Time. ULA is using the Atlas V 401 configuration to launch GPS 2F-12. This is the 61st Atlas V evolved expendable launch vehicle flight since the inaugural launch in 2002, the 31st flight of the 401, and ULA's 104th mission. A number of important milestones took place leading up to launch. The Atlas V launch vehicle is produced in Decatur, Alabama, and Harlingen, Texas. It is comprised of a Common Core booster powered by the NPO Energomash RD-180 main engine and a Centaur upper stage powered by the Aerojet Rocketdyne RL-10C. The GPS 2F-12 satellite is protected during ascent by a 4-meter diameter payload fairing. Launch processing here at Cape Canaveral began with the arrival of the Centaur second stage on December 18th, followed by Atlas V booster arrival on December 20th. The Atlas V booster was erected on its mobile launch platform inside the vertical integration facility on January 11th, with Centaur stacking a day later. A week later, on January 19th, the GPS 2F satellite was encapsulated inside the 4-meter payload fairing. Then on January 30th, the encapsulated payload fairing was transported to the vertical integration facility and mated to the Atlas V booster. Yesterday, at approximately 8 a.m., the fully integrated Atlas V on its mobile launch platform was rolled to the pad at Space Launch Complex 41. Track mobiles are used to transport the mobile launch platform to the launch pad, which is a quarter-mile trip that takes about 30 minutes to complete. Once the mobile launch platform reaches its park position at the pad, the team conducts final securing. Following pad clear, at about 4 hours before liftoff, the Atlas V is fueled and configured for launch. The Atlas V rocket stands 189 feet tall, or about 19 stories, and weighs more than 700,000 pounds fully fueled. To lift the Atlas V away from the pad, approximately 860,000 pounds of thrust is produced by the RD-180 engine. This is Atlas Mission Control at T-minus 4 minutes and holding. The GPS-2F satellites are part of the 4 generations of operational GPS satellites on orbit. With a total of 30 operational satellites, GPS is the largest constellation in the Department of Defense, as well as the most robust and capable system in the history of space. From their vantage point in the semi-synchronous circular orbit, the GPS-2F satellites provide improved accuracy through better clocks and a longer design life. Here's a video detailing GPS-2F-12's trip to orbit.
The following profile details the important events of this mission using approximate times.
5, 4, 3, 2, 1, 0. And liftoff of the Atlas V rocket.
The Atlas RD-180 main engine ignites to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 78 seconds. At 90 seconds, the vehicle experiences maximum dynamic pressure. Approaching booster engine cutoff, the Atlas V is burning propellant at the rate of 1,600 pounds per second, traveling at approximately 16,000 miles per hour, and located 62 miles in altitude and 146 miles downrange. Booster engine cutoff occurs approximately 4 minutes after liftoff. 6 seconds after booster engine cutoff, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. The payload fairing is jettisoned approximately 4.5 minutes into the flight. Cutoff of the Centaur main engine follows an approximately 13-minute burn. The mission now enters a 3-hour coast phase. At 3 hours 17 minutes into the flight, the Centaur main engine is started for a second and final burn. This burn will last approximately 1.5 minutes. Following the second Centaur main engine cutoff, the mission enters a final 5-minute coast phase. At 3 hours 23 minutes, Centaur releases the GPS satellite for the United States Air Force.
This is Atlas Mission Control at T-minus 4 minutes and holding. This morning's flight is dedicated in memory of retired ULA employee Kirk Webbink. During his 34-year career at Martin Marietta, Lockheed Martin, and ULA, he designed harness installations for the Titan II, Titan IV, and Atlas launch vehicles. One of Kirk's proudest accomplishments at work was his part in the design of the Manned Maneuvering Unit, or MMU, used by the astronauts on the Space Shuttle program. Kirk was both a supportive coworker, sharing his wealth of design knowledge, and a consummate professional, always able to deliver a quality product while adapting to design changes and keeping with the rapid launch rate. Kirk was also a caring individual, dedicated to his career, family, and friends. He was well respected and always willing to lend a helping hand. Kirk was an avid stargazer, and his star shines bright above us today. With this morning's mission, we also remember Aerojet Rocketdyne employee Thomas Davis. Tom joined Pratt & Whitney in 1961. As a young systems engineer, his first assignment was on a relatively new rocket engine program called the RL-10. Over the next 54 years, Tom would dedicate 46 years of his career to the RL-10 program. Known to his co-workers and customers as Mr. RL-10, Tom knew everything about the engine and was responsible for training generations of engineers on the performance and operation of the RL-10. During his career, Tom played a key role in several major events that built the strong legacy of the RL-10. This included the first in-space firing of the world's first liquid hydrogen, liquid oxygen fueled rocket engine, the development of 13 derivatives of the original RL-10 engine that have powered Atlas, Delta, Titan, and Saturn upper stages, The direct involvement in over 14,000 firings of the engine, which accumulated more than 2.3 million seconds of engine hot fire time, and the successful launch of numerous military, government, and commercial satellites to orbit, empowering space probe missions to explore every planet in our solar system. Tom will forever be fondly remembered as Mr. RL-10 and deeply missed by his colleagues and friends. This is Atlas Mission Control at T-minus 4 minutes and holding. In a few moments, launch conductor Ed Kidda will pull the team for the final go to pick up the countdown. 27 engineers and managers will be pulled for system status and readiness to proceed. This is the final status check before launch for all vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The readiness pull includes hydraulics, pad water deluge system, electrical system, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as launch conductor Ed Kidda performs the final pulling of the team.
Status check to proceed with terminal count. Atlas systems, propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2. Go. Water. Go. Centaur systems, propulsion. Go. Pneumatics. Go. LO2. Go. LH2. Go. Has gas. Go. Electrical systems, airborne.
Go.
Ground.
Go.
Facility. Go. RFFTS.
Go.
Flight control.
Go.
Com.
Go.
Timer.
Go.
GC cube. Go. Umbilicals. Go. ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
AC is go.
Range coordinator. Clear to proceed. Launch director.
LD is go. The launch vehicle is ready to launch.
Mission director.
This is the mission director. You have permission to launch.
Proceeding with the count. T0 is planned for 1338 Zulu. Set count to start at 1334 Zulu.
T0 is set for 13.
Polling is complete and the team is given the go for launch. The countdown will resume in approximately 2 minutes. From T-minus 4 minutes until launch, you will be listening to launch conductor Ed Kidda and his team performing the final steps in the countdown procedure. You'll hear the team confirm securing of the Atlas liquid oxygen topping, followed by the call to transfer the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur liquid hydrogen and liquid oxygen topping activity. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, the Atlas tanks will be verified at flight pressures, followed with the verification of the Centaur tank pressures. A final status check of Atlas, Centaur, and GPS IIF-12 readiness is conducted at T-minus 25 seconds. Seconds before liftoff, the RD-180 engine ignites and performs a health check before lifting the vehicle off the pad. After liftoff, you'll hear the voice of Marty Milanowski providing launch vehicle ascent data. This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
2, 1, mark.
355.
The countdown clock is resumed and we are proceeding towards an 8:38 a.m. Eastern liftoff.
3 minutes.
Securing LO2 topping.
Atlas tanks to flight pressure.
250. FGS internal.
T-minus 2 minutes, 30 seconds and counting. Once the rocket lifts off, it will only take about 78 seconds to reach Mach 1, or the speed of sound.
$159.
Vehicle internal.
$155.
Launch sequencer start.
$150.
Securing Centaur LH2.
Securing Centaur LO2.
$140.
FCS launch enable.
FTS armed.
T-minus 1 minute, 30 seconds and counting. The launch vehicle payload, vehicle, and ground systems and Eastern Range are a go for launch.
120.
OCUs armed. FCS count started.
110.
Vent valves locked.
$60 seconds.
T-minus
Roger.
1 minute.
$40.
Stable at step 3.
T-minus 30 seconds.
25.
Status check.
Go Atlas.
Go Centaur. Go GPS.
20. 15. 10.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. RD-180 ignition. And we have liftoff of the United Launch Alliance Atlas V rocket carrying the 12th GPS 2F satellite for the United States Air Force. The Global Positioning System provides worldwide positioning, navigation, and timing service for military and civilian users.
Control.
You are
Good job,
hearing the
roll
voice
call.
of Marty Malinowski, here providing launch vehicle ascent data.
Speeds and injector pressures continue to look good. RD-180 continues to perform well. And the roll program is now complete. Body rates look good. Engine performance continues to look good as well. Coming up on Mach 1 momentarily. Mach 1. Body rates continue to look very good. Engine performance is steady. Max Q, booster has throttled back as expected. Engine signatures look good. Body rates continue to control right down the middle. Current altitude is 13 miles, downrange distance 8.5 miles. Current velocity is 2,200 miles per hour. Booster performance continues to look very good. Body rates are smooth. Coming up on our closed loop steering segment. And closed loop steering has been enabled. Also a minor roll. RD-180 pump speeds and injector pressures continue to look good. Our CS pyro valve has been fired. System's now pressurizing to flight levels. Signatures look good. Booster performance continues to look very good at this point. Pitch yaw and roll, controlling right down the middle. We've ended the Q alpha limited steering and throttled back as expected. Engine signatures look good. Coming up on our 5G throttle segment. And we have begun throttling to maintain 5Gs. Boost phase chill down is underway. Signatures look good. Pump temperatures are as expected. And we've begun throttling to 4.6 Gs in preparation for BECO. Boost phase cool down is complete. And we have BECO. Engine shutdown looks good. And we have stage separation. Looks like a clean SEP. We have LOX and fuel pre-start on the RL-10. GN2 purge firing's underway. We have RL-10 ignition and full thrust. Coming up on payload fairing jettison, and we do have indication of a good payload fairing jettison. All signatures look good at this point.
This is Atlas Mission Control at T plus 4 minutes 40 seconds. We've just heard Marty Milanowski report the successful execution of the events comprising the early part of today's mission, and all systems to continue to operate nominally. The mission is currently in the first of 2 Centaur engine burns. Our next event, Centaur main engine cutoff, will occur in approximately 12 minutes. I'm now joined by the Air Force's Lieutenant Jason Fischbach from the Global Positioning Systems Directorate. Lieutenant, thanks for joining me today.
Thank you for having me. It's an honor.
Great. Can you tell me just a little bit about yourself?
Okay, as you said, I'm Jason Fischbach. I'm from the Republic of Panama. I come from a family of enlisted veterans. I'm married. I have 2 wonderful sons. When I was growing up and we didn't have enough money for college, it became an easy decision to join the Air Force. So I joined the Air Force about 18 years ago, and after balancing school and work for about 15 years, I finally earned my bachelor's degree in electrical engineering. Shortly after that, I became the first person in my family to become a commissioned officer, and I've been working with the GPS Directorate ever since. I started off 3 years ago with the GPS Directorate. The first 2 years I worked as government lead for the GPS-2F production line, and that was an awesome opportunity. I saw everything from every stage of build and test of the GPS-2F satellites. Then I went on to what I'm currently working, which is the next generation command and control system.
Great. Well, congratulations on all you've accomplished so far. That's quite a feat.
Thank you so much. I really appreciate it.
Since you're very knowledgeable about the GPS program, can you kind of give us a current status on the GPS constellation?
Of course. The GPS constellation remains stable, healthy, and robust. With 30 operational satellites on orbit, the constellation is comprised of 19 GPS-2R and 2RM satellites and 11 GPS-2F satellites. The GPS-2R and 2RM satellites, also known as the GPS legacy satellites, have exceeded their life expectancy. In fact, 18 of the 19 that are on orbit today have exceeded the 7.5 year design life. Regardless of that feat, they continue to provide reliable position, navigation, and timing services.
That's great. I'm really glad because of the lifetime of the satellites is kind of ending here. I'm glad we're helping you launch a new one today.
Yes, the GPS-2F satellites are
Yes.
vital to the modernization of the constellation, and in order for us to maintain the level of reliability and precision that GPS delivers to users worldwide each and every day.
Can you tell me about some of the capabilities that the 2F satellites bring to the GPS constellation technically?
Of course. The 12 Boeing-built GPS-2F satellites have improved signals, which will enhance the precision of the global position navigation and timing services provided both to support both the warfighter and the growing civilian needs of our global economy. The GPS-2RM was the satellite that directly preceded the GPS-2F satellites, and it introduced the L1 signal, one new L1 signal, and it introduced two new L2 signals. The GPS-2F satellites introduced one new L5 signal. So L1, L2, L5, what all that means is it's just basically a portion of the frequency spectrum. The L1 signal carries probably the most commonly known signal, the L1 course acquisition code, and that's the most commonly known because that's what you're going to have on your GPS watch, your GPS navigation system in your car and stuff like that. The L1 also carries a code called precision code, PY code, and that's for military applications, and it also carries L1M code. The L2 frequency carries L2C, which is a modernized civil signal. We'll talk about why that's important here in a sec. The L2PY, precision code for military applications, and L2M for military applications as well.
Great.
The L5 signal, which is brought by this GPS-2F, is safety of life. It's going to be used for safety of life applications, including aviation applications. The great thing about the GPS-2F satellite is that it has all those signals on board in the navigation payload. And those signals carry information like the GPS date and time, satellite ephemeris, satellite state of health, and ephemeris is basically the location of that satellite. And it also includes almanac information, which is all that other information for the rest of the satellites in the constellation.
Great. Powerful satellites.
Yes. One last thing I wanted to mention was that modernized signal, what that has, that enables this thing called ionospheric correction, which will greatly improve accuracy to all the users.
Amazing. So we've talked a lot about what we've done in the past with GPS. Can you tell us a little bit of what's in store in the future for the GPS program?
Yes, the GPS program has a lot of modernization efforts currently underway across the space, ground, and user segments. Those modernization efforts include improved or stronger signals. It includes additional civil signals. It includes improved robustness of the overall system architecture, and it includes advanced user or advanced receiver techniques for the GPS military user equipment.
Great. So in terms of your satellites, what's next for GPS?
Okay, so we just, as you see, we just launched the last GPS-2F. We're going to be the next satellite that's currently in development is known as the GPS-3 satellite. Its first satellite, SV-1, has just completed baseline thermal vacuum testing, or TVAC. As you know, TVAC is one of the most comprehensive, perceptive, and critical tests that we have in use today.